problem here, we have a parabola, and if the parabola is in the form y equals ax squared plus bx plus c, which could be the value of a plus b plus c, so this is a plus b plus c, such that the parabola will have two solutions, two zeros. So if you take a look, some things we know I've written out here. The vertex, since it's 9, negative 14, we know that negative b over 2a is 9, or we know that b is negative 18a. We also know the vertex form is a times the quantity of x minus h squared plus k, which I have replaced the h and the k with 9 and negative 14. If you multiply that out and you kind of line things up, the x squared term doesn't tell you much. The bx is equal to negative 18ax. That gives you the same thing that the vertex formula gives you. And then we have this c is 64a minus 14. And what else do we know? Well, if our vertex is down in the fourth quadrant, for it to hit the x-axis twice, that a value has to be positive, okay? So what I did is I know that if a plus b plus c is equal to negative 12, I started with that one. Then I put a is a, b is negative 18a, c is 64a minus 14. And then if you solve, you do get a positive value of 2 over 47. If you try any of these other ones, you don't get a positive a value, you get a negative a value. So that's why negative 12 works. So there's a little bit about that one. And now if you go into chapter 28 in your book, I'm going to go through some of the geometry problems for you. It says if the triangle shown, or in the triangle shown, A is 45 degrees, what is the value of B? Well, we know that A, which they told us is 45, plus 31 plus 2B has to total up 180. So we're just doing a little math there. This is 76. 180 minus 76 is 104. Half of 104 is 52. So B is A. The answer is A, 52. Let's take a look. Number 2. A cube has a surface area of 54. What is the volume of the cube? Well, if you think about, even if you don't know the formula, the volume of the surface area of a cube, each one of these sides is, we'll call it X. And there are 6 faces that look exactly like that. So 6x squared. And I believe that might be one of the formulas on your reference sheet. But if you forget a formula, always look back at that. So we know that 54 is equal to 6x squared. If we divide by 6, we get that 9 equals x squared. So x is the square root of 9. We don't have to use that plus or minus because it's a length. So we get 3. Now, that's a side length. Then it says, what is the volume? The volume is length times width times height, or side cubed. So in this particular case, that would be 3 cubed. The volume is 27, which is B. Let's take a look at this. Excuse me. In the xy plane, a circle with radius 5 has a center of negative 8, 6, which is the following equation. So you need to know x minus h squared plus y minus k squared equals r squared. And we're just going to plop that information in. See this negative here? That should tell you to flip that sign. So we're going to get x plus 8 squared, y minus 6 squared equals 5 squared. Or again, that would be 25. So the one that matches that is B. Let's take a look at number 4. It says in the figure shown, lines T intersects line L and K, and which of the following statements, if true, would imply that lines L and K are parallel? Well, if this is a transversal and these two things would be parallel, X and Z would be supplementary. Those are same side exterior. Um, W and Y and Z, and this one right here, would all be the same. So if we have W equals Y or W equals Z, that would be true, but these are just equal, not due to the fact that they are parallel, but because they're vertical angles. So only when you connect it with the one down here, so W equals Z, would it give you what we're looking for. So there you go. Number 5. In the right triangle, the tangent of one of two acute angles is square root of 3/3. What is the tangent of the other acute angle? So although this isn't going to be perfect, we'll call our first acute angle A and our second acute angle B. So what they've told us is that the tangent of that acute angle A is radical 3/3. So let's put in what we know. That we could then build a triangle. One triangle that would fit this scenario would be when the opposite is radical 3 and the adjacent is 3. Now, that's great. That's wonderful. That's what we want. But what we can say now is if we just focus on the other one, it says, what would the tangent of the other angle be? Do you see how the opposite now is 3? The adjacent now is radical 3. So the tangent of B just flips it over. So it'd be 3 radical 3. So in a right triangle, if you were looking at the tangents of the two acute angles, they will always be reciprocals of one another. And that's just the tangent. The cotangents would be too, but so there you go. It says in number 6, point C is at the center of the circle shown. What is the measure of angle ACB in radians? So they're really saying 90 degrees is how many radians? Well, the thing to remember is that 180 degrees is 2 pi worth of radians. So if you cut this in half, just cut this in half. I'm sorry, 180 degrees is pi worth of radians. I think I said that, but I did not write that. So if you cut that in half, 180 degrees divided by 2 is 90. Pi divided by 2 is also would be equivalent to 90 degrees. So pi is 180 degrees. So half of a pi is 90 degrees. So that would be that one. Let's look at number 7. It says the length of one side of a square M is 5 times the length of another square N. Okay, so I'm just going to say that M is 5N. The area of square N is 361. What is the area in square centimeters of square M? Well, we know that that would mean that N squared is 361. So M squared would be 5N squared, or 25 times 361, which is 9,025.